Good afternoon, everyone. So today we are going to discuss mock test 2, and obviously you can read the instructions from the question paper which will be there. So I'm not repeating the instructions. So let's just begin with the first question. Now he says if x minus 23 into y minus 56 whole divided by x minus 23 whole square plus y minus 56 whole square is equal to minus 1 by 2, then write the value of x plus y. Right? Now, as you can see, I have x minus 23, then I have x minus 23 whole square. Right? Same term is occurring here. And y minus 56, y minus 56 whole square. Right? Rather than writing the same term again and again, what I'll do is I can substitute x minus 23 as A and I can substitute y minus 56 as B. You can make do without substitution also, but I think with substitution you are able to see the solution better. Right, so this becomes A, this is B, so AB, whole divided by, this is A square plus B square. This is equal to minus 1 by 2. Right, if I cross multiply, basically I'll get A plus B whole square. As you can see, why? Because minus A square minus B square, if I shift to this side, so A square plus B square plus 2AB, which is A plus B whole square, which is equal to 0. Right, that means A plus B is equal to 0. Now A was nothing but x minus 23. Plus b, which was nothing but y minus 56. From here you can get the value of x plus y, which turns out to be 79, which is the answer. Alright, let's move on to the next question. He says, a 3 into 3 square frame is placed on a grid of numbers. You can see grid of numbers and 3 into 3 square frame. So basically, if you can see, this is the 3 into 3 square frame is placed. In the example, the sum of numbers inside the frame, right? So as you can see, I have 4, 5, 6, 11, 12, 13, 18, 19, 20. And the sum of these numbers is given to be 108. And the middle term, as you can see, that is 12. Right? Now he says when the frame is moved to a new position, the sum becomes 288. Right? So if I shift this somewhere else, the sum of the numbers is given to be 288. In this position, what is the middle number? Right. Now, if you can observe, the sum of the numbers is 108 and the middle term is 12. So, you can see that 12 and 108 are directly related to one another. Right. This is nothing but 12 into 9. Now, is that a coincidence? Let's check it out. Now, the middle term is 12, right? Okay, so 12 is there. So, 12 plus. Now, this number is nothing but 12 plus 1. Right, 13. And this is obviously 12 minus 1. Right? Okay. And if I go back to this number, this is nothing but 12 minus 7. So let me write it here. 12 minus 7. And if I'm talking about this number, that is 19, 12 plus 7. 12 plus 7. Right? So I'm done with these. So let me go back here. So this is 12 minus 8. This is 12 plus 8. So 12 minus 8. And 12 plus 8, right? So these two numbers are also done. And this is 12 minus 6, 12 plus 6. So these two numbers are also done. So I should have actually written it here, 12 minus 6 and here 12 plus 6. This sum is given to be 108, which was very obvious. Why? Because minus 8, 8, minus 7, 7, minus 6, 6, minus 1, 1, and obviously 12 is there. So you can see 9 into 12, which is 108. Right? So if the sum of the numbers is 208, the middle number what should be? What should it be? It should be 288 divided by 9, which is nothing but 32, which is the answer. Right. On to the next question. He says let n, which is a raised power p into b raised power q into c raised power r, be the smallest positive integer such that n by 3 is a perfect square, n by 5 is a perfect cube, and n by 7 is a perfect fifth part. Then write the value of p plus q plus r. So p plus q plus r. In short, if I am able to determine what n is, I can write this value. Right? Now what is given to me? It is the smallest positive integer. N by 3 is a perfect square. That means n should have a factor of 3, then only I'll be able to cancel out some factor, right? So, if I'm talking about the prime factorization of n, I will have 3. Also, n by 5 is a perfect cube. That means the prime factorization should have the prime factor 5. Right? And as you can see, prime factor 7 should be there. Now, since I want the smallest number, that means these 3 prime factors will be there. What are the powers that I need to determine? Right? So, let's move on to that. So, let me first try to establish the power of 3. So, let's talk about powers of 3. Right? Now, he says, now n by 3 is a perfect square. Fine, we'll come back to that. Now, he says n by 5 is a perfect cube. Now, here obviously I'm not cutting down the factor of 3. That means it should have the factor of 3 and it should be a perfect cube. Now, do you think I can have 3 raised to 1? No, because I want a perfect cube. So, do you think I can get 3 square? No. I can have 3 cubes. So, that means the power of 3 can be 3. It cannot be 4, it cannot be 5 because I want a perfect cube. It can be 6, it can be 9, it can be 12 and so on. Done? Now, he also says that n by 7 is a perfect fifth part. That means the factor of 3, the power of 3 should also be the perfect fifth part. That means I cannot have 3 squares. I cannot have 3 raised to 4. I can have 3 raised to 5. Right? So, powers of 3 has to be one of these, 5, 10, 15 and so on. Now, both the conditions have to be satisfied. That means I will look for the common elements. Now, the lowest one I want, so 3, 6, 9, 15. 15 is the lowest number which occurs here as well as here. Right? So, maybe the power of 3 can be 15. Let me check whether this is the case. Why? Because I need to check whether this is satisfied or not. So, n by 3, if I cut one factor of 3, I'll get 3 raised to 14, which can be a part of a perfect square. So, it's absolutely fine. Right? Now, let's move on to power of 5. So, powers of 5. Right? Now, first of all, let's come back to this. N by 3 is a perfect square. That means the power of 5 has to be even because it has to be a perfect square. So, it can be 2, the power can be 2, it can be 4, it can be 6, it can be 8 and so on. Right? N by 5, let's just leave it here. Let's talk about this. N by 7 is a perfect fifth power. That means power of 5. It can be 5, it can be 10, it can be 15 and so on. Now, since both the conditions have to be satisfied, so I need to look for common elements. Again, I can see that is 10. Right? So, maybe the power of 5 can be 10. Let me check whether it is satisfied by this or not. Right? 5 raised to 10 divided by 5, that will be 5 raised to 9, which can be a part of a perfect cube. Right? So, 5 raised to 10 is absolutely fine. Now, let's come to powers of 7. Now, n by 3 is a perfect square. That means power of 7. It has to be even. So, 2, 4, 6, 8, 9, not 9, 10 and so on. Then, n by 5 has to be a perfect cube. That means power of 7 has to be a perfect cube. So, that means it can be 3, 6, 9 and so on. Both have to be satisfied and the lowest one that I can see, that is 6. So, power of 7 can be 6. But I need to check here. So, 7 raised to 6 divided by 7, that is 7 raised to 5, which can be a part of perfect fifth power. So, this is the lowest number which is 1. Right? If I compare it to this one, I can say P can be 15, Q can be 10, R can be 6. The answer will be 31. Alright, let's move on to the next one. He says write the number of non-congruent triangles with all sides as natural numbers and perimeter equal to 17. Right? Now, perimeter is equal to 17. That means sum of all the sides is 17. So, let me consider my sides to be x, y and z or z. Perimeter 17, that means x plus y plus z is equal to 17. Now, he says that all sides are natural numbers. So, that means each of these, they belong to the set of natural numbers and non-congruent triangles. Now, minded, I can start because I can write the solution of this equation. That is not a big deal because over the set of natural numbers. But minded, I have to make sure that the triangle is formed. Right? Now, is there a relationship between sides of the triangle and the formation of triangles? What is that one condition that has to be satisfied in order for the possibility of triangle? That is, sum of two sides have to be greater than the third one. Or in a refined way, I can say sum of the smallest two sides have to be greater than the third one. Right? So I have to make sure. Now, if I want to make cases, I have to make case of this. I have to make note of this. Now, let's see. The question is, should I start with the case? Let me take x as 1, y as 1, and z as 15. Obviously, this triangle is not possible. Then I'll go to 1 to 14, stuff like that. Again, you can see that these all triangles are not possible. Right? So, if I want to make a better case, what I'll do is, I will locate the highest or the longest side which is possible. Longest side of the triangle. Right? Let me say, if I take x to be 8, the sum of these two sides is 9. Right? Sum of these two sides is greater than the third one. Perfect. Right? Now, if I take my x to be 9, sum of these two sides is what? 8. Sum of these two sides is not greater than that one. So that means x equal to 9 is rejected, x equal to 10 is rejected, x equal to 11 is rejected, and so on. The longest side which is possible, that is 8. Longest side is 8. Right? So let me start with that. Now, let me take my x to be 8. Now, y plus z is 9. So, let me say. So, 1, 8 I can have. Right? Triangle is formed. Then, I can have 2, 7. 8, 2, 7. Triangle is formed. Then, maybe I can have 8, 3, 6. That is fine. 8, 4, 5. Absolutely fine. 8, 5, 4. Yes. But, he says non-congruent triangles. Clearly, these two triangles are congruent. That means, I will not take this case. Then obviously I will not take 863, 872, 881. I will not take because I have taken all of these. Right? So I have exhausted the case when 8 is the longest side. Now the longest side, it cannot be 9. Oh, I have to go in the reverse direction. So longest side can be 7. If x is 7, sum of these two sides is 10. Right? So maybe I can have 1, 9. Careful. Right? I said the longest side is 7. Here you have 9. That is not possible. Right? So maybe I can have 2, 8. Is that okay? Again, no. Longest side is 7. You have 8 over here. So no. Then I can have 3, 7, which is absolutely fine. Then 7, 3, 4, fine. 7, 4, 6 right? 4, 6, my bad. 7, 4, 6 is fine. 7, 5, 5, that is fine. After that, the cases will start to repeat. Right? So that means longest side 7 cases exhausted. Now, let's move on to longest side, that is 6. Now, if x is 6, sum of these two sides is 11. So, obviously, I cannot have 1, 10. I cannot have 2, 9, 3, 8, 4, 7. No, 5, 6 I can have. Right? Next would be 6, 6, 5. But obviously, congruent chain, so rejected. Right? Next, the longest side can be 5, but all of those cases have been done. Right? So that means our cases are done. How many triangles are there? 4 here, 3 here, 1 here. So that means in total 8 triangles will be possible. That is why your answer is 0, 8. On to the next question. Now he says if f of x be a polynomial of lowest degree with rational coefficients, lowest degree and rational coefficients, of which one root is given to be there. The better word should have been 0, but it's fine. You get the gist of it. Right. So lowest degree polynomial with rational coefficients and 1, 0 is given to be that. Suppose the coefficient of the linear term is minus 18, then write the numerical value of the constant term of f of x. If I'm able to write the polynomial f of x, I can write the constant term and the numerical value. Right. Now, let's just study. One root is this. And I want a polynomial with rational coefficients. Right? So, if I am considering my polynomial in x, I know one value of x is nothing but cube root of 3 plus 2 into cube root of 9. Right? Using this, I need to make a polynomial with rational coefficients. That means radical sign should not be there. Now, radical sign, I want to remove it. And obviously, let me see. I cannot leave it like this. Radical signs are there. If I square it up, radical sign will not disappear because I want to get rid of cube root. If I want to get rid of cube root, that means I need to cube it. So I can do that. X cube is equal to cube root of 3 plus 2 into cube root of 9 whole cube. Right? Because clearly if x is equal to this, x also satisfies this equation. Right? So, a plus b whole cube, I can write it. So, that is a cube, which is 3, plus b cube, which is 2 into cube root of 9 whole cube. So 2 cube, that is 8. 8 into 9, that is 72, plus 3ab. So ab. So multiply that. So cube root of 3 into 2 into cube root of 9 into a plus b. Right? 3ab into a plus b. Now a plus b, you have substituted as x. Right? This is equal to x cube. If you simplify it, you will get x cube minus 18x plus 7 minus 75, that is equal to 0. Right? The polynomial f of x is this one. X cube minus 18 minus 75. Right? Lowest degree polynomial, rational coefficients, and obviously one of the root is this. Right? Now he says, write the numerical value of the constant term. Constant term is what? Minus 75. I just want the numerical value, as in the number associated with it, which is 75, which is the answer. Alright, so the next question is, if m is the average value of absolute value of a1 minus a2 plus absolute value of a3 minus a4 over all permutations of a1, a2, a3, a4 over 1, 2, 3, 4. Right, then write the value of 9m. Clearly, I need to find the value of m. Right, now he says m is the average value of this over all permutations. Now, average is what? Sum of all observations divided by total number of observations. Now, total number of observations. Now, he says over all permutations of A1, A2, A3, A4 over 1, 2, 3, 4. Right? So, I have four distinct numbers, four distinct objects. So, in how many ways can I do that? I can do that in 4 factorial ways, or you can say 24 ways. Right? So, total number of cases, in this case, that is 24. If I want to find the value of m, I need to find the sum of all the cases. Right? So, let me just try to start the question. Now, he says absolute value of a1 minus a2 plus absolute value of a3 minus a4. So, let me just write the cases. Right? Permutations. Let me take a1 as 1, a2 as 2, a3 as 3, a4 as 4. In that case, that will be mod of minus 1, which is 1, plus mod of minus 1, which is 1. Again, in this case, the sum would be 1 plus 1, which is 2. Right? Now, permutation. So, let me take a1 as 1, a2 as 2, a3 as 4, and a4 as 3. In this case also, this is 1, this is 1, this will become 2. Right? What else? So, 1, 2 I have exhausted. So, let me take 1, 3. Then I can take 2, 4 here. Right? Mod of minus 2, that is 2. Mod of minus 2, which is 2. Sum would be 4. Right? Then 1, 3, 4, 2. Sum is again 4. Right? Then 1, 3 exhausted. 1, 4 I can take. Right? So this is 2, 3. In this case, 3 plus 1, which is 4 again. Then 1, 4, 3, 2. Sum is 4 again. So I've exhausted all those cases where A1 is 1. Right? The sum in this case, that is 1, 2, 3, 4, 5, that is 20. Right? Now, if you write those cases where where A1 is 2, the sum will again turn out to be 20. Right? So, 20 plus 20. When A1 is 3, again it will be 20. When A1 is 4, again it will be 20. Right? These are the all cases possible, as you can see, because 6 plus 6 plus 6 plus 6, that is 24, which we have already written. So, this is nothing. This is the value of m. Just multiply by 9, you'll get the answer, which is 30. Alright, let's move on to the next question. He says a ball is thrown from a window at the point 0, 2. So, ball is thrown from here. Obviously, it travels like this and then hits the ground. Right? The ball flies through the air along the parabola, as you can see, with the equation there. So, equation of this parabola is y is equal to a into x minus 1 whole square plus 8 by 3. For some real number a. Right? So that means in this equation there is a parameter a which is not known yet. Right? Write the positive d for which ball hits the ground at d, 0. Right? So I need the value of d. Right? Okay, how should I get the value of d? As you can see, this point lies on the parabola. Right? That means this point should satisfy this equation. Right? So that means if I substitute x as d and y as 0, the equation should be satisfied. But there is one problem. As you can see, we have a variable here which is a. Till the time I do not know the value of a, I will be unable to ascertain the value of d. Right? Now, what else do I know? Yeah, I know that the ball is thrown, what, from which point? 0, 2. Now, if you can trace it, this is a parabola, this is a parabola. That means this point also lies on the parabola. So, y is equal to a into x minus 1 whole square plus 8 by 3. I know that 0, 2 lies on the parabola. That means 0, 2 will satisfy this equation. So, if I substitute x by 0 and y by 2, I will get the value of a. Now, once I get the value of a, substitute it and do the thing again and you will get the answer. And the t will turn out to be 3. That is why your answer is 0, 3. Alright. So, the next one. A subset P of the set of first 200 positive integers. So, that means I need to consider the integers 1, 2, 3, so on till 200. Has the property that no two elements of C sum to 225 or 335. 235. Yeah, 235. Alright, let K be the maximum possible number of elements in P. K is the maximum possible number of elements in P. Right? Then write the square of the sum of digits of K. Basically, I need to find the value of K. Right? Now, I know that no two elements should sum to 225 or 235. So, let me take, and I want the maximum one. Now, if I take 1, I have no issues because I would need 224 in order to make the sum 225. Obviously, 224 is not available to me. Right? I can take 2, I can take 3. I have no problem till 24. Right? But if I take 25, I cannot take 200. Right? Why? Because the sum is 225. Right? Okay. What else? If I take 26, I cannot take 119. Why? Because the sum is 225 again. Right? Okay. Now, if I take 225, 215. If I take 35, I cannot take 190. Also, I cannot take 200. But that I have already not taken here. Right? Okay, so that's absolutely fine. Let's move further. Now, if I take 45, I cannot take 180. And considering that, I cannot take 190, which already I have not taken, so it's absolutely fine. Right? Then, let me increase. So, let me add 55 itself, so on. I can take 100. Right? And this would be 155. So, 125. And then I cannot take 135, which must have been already rejected here. So I don't care about these. Rejected, right? Then I take so on 112, 113, right? And this is 123, which I must have already rejected. So I don't care. Right? Now if I take the next one, 113, right? 112, this case is already done. So be careful, right? And now you can see that all those cases have been kind of repeated. So I don't need further ones. So that means the maximum possible number of elements. So 1, 2, 3, so on till 35, so on till 45, so on till 100, so on till 112. So 112 is the maximum possible number of elements in P. So K is 112. You can find the value square of sum of digits of K, which turns out to be 16. Alright, so the next one. A rectangle having sides 36 cm and 48 cm is separated into two triangles by the diagonal. So let me make the rectangle first. So this is my rectangle. Now 36 and 48. So this is 36 and this is 48. Now it is divided by the diagonal, which is this one, into two triangles. A circle is inscribed in each of these triangles. So inscribed, so my circle would look something like this. And the other circle would look something like this. Right? Now he says let D be the distance between their centers. So this is the center, this is the center, D is this distance. Right? Now he says write the value of root 5 into D. So basically I need to find the value of D. Right? Okay. Now I have to make use of the fact that this is a rectangle. That means this angle will be 90. Okay. Now this is 36, this is 48. In short, I know the length of the diagonal, right? 36, that means 6, 8, 10. So 6 into 6, 6 into 8, 6 into 10, that means the length of the diagonal is what? 60? I have to use the fact. Now he says distance between the centers, right? So let me just first try to find out what I can find out. Now right triangle is there, circle is inscribed. Can you find the radius of the circle? I think we can very well do that. So this is 36, 48, 60. This is my circle. So I know if I join the point of contact with the center, that is यहाँ पे 90 होगा. This is radius. Join the point of contact with center. This is 90. This is R. This is 90 because right triangle. So basically this becomes a square. Now this is R. This is R. Now entire was 48. This is R. That means this is 48 minus R. Remember? Right now this is a point outside the circle. So that means this length would be equal to this length. Right? This is 48 minus R. This is 48 minus R. Right? We'll do the same thing here because this is R. This becomes 36 minus R. And this becomes 36 minus R. Now 48 minus R plus this one, 36 minus R, is equal to the entire length, which is 60. From here, you'll find that R turns out to be 12. 74, 84, right. R turns out to be 12. So radius of the circle turns out to be 12. But I'm interested in the distance between the centers. Mind it, I have to use the fact that this is a rectangle. Now tell me distance. Now distance, if I want to find out, I can use Pythagoras theorem, first way. Second way is, maybe I can find the distance between the 2 points provided I know the coordinates. Right? Coordinates. Now for that, I need to have a coordinate system. The coordinate system is very visible to you. This is 90. Let me take this as x and let me take this as y-axis. Right? Now, if I'm interested in the coordinates, that means this distance I'm interested. This is obviously 12 equal to the radius. So, x coordinate is 12, comma. Now, I need the y coordinate. Y coordinate is, if I drop the perpendicular here, this distance. Now, this entire distance is how much? 36. Right? Out of 36, obviously this is 12. That means this distance is 24. So, y coordinate is 24. Right? Now, let's come back to the coordinates of this point. So, if I drop a perpendicular from here, I need this length. Now, this entire length is 48. This is 12. This is 48 minus 12, which is 36, comma. Now, obviously this length is 12. So, this is 12. Right? I know the coordinates of this point. I know the coordinates of this point. I can find the distance between the two coordinates. Right? Using distance formula. For the younger class kids or the lower class kids, they can use Pythagoras theorem. You'll get the answer. The answer turns out to be 60. Alright, so the next one. He says, what is the number 43 if 8 into 8 is 54? Now, in usual system, 8 into 8 is definitely not 54. Right? That means the base involved here is not decimal base. Or we can say base 10. Right? It is some other base which I need to evaluate. Now, I don't know what that other base is. But whatever the case may be, the base, the number 54 is in that base. Right? So let me suppose my base to be x. Right? Okay. So can you tell me the place value of this one? Obviously, if the base is x, the place value of this place would be x raised power 0. And place value of this place would be x raised power 1. Right? So if I write the number in the expanded form, it will be 5 into the place value, which is x raised power 1. So let me just write it as x plus 4 into x raised power 0, which is 1. Right? So this number is nothing but 5x plus 4. Right? Now, if 8 into 8, which is equal to 64 in the decimal system, or we can say base 10, this number should have been equal to 64. Right? Because the expanded form remains the same in all the bases. Right? So, 5x plus 4 should have been equal to 64. Right? From here, you can say 5x equal to 60. X will turn out to be 12. That means the base that you are working in, that is base 12. Right? Now, let's read the question carefully. He says, what is the number 43? If 8 into 8 is equal to 54. That means the base, that the system that we are using, that is base 12. And 43 is given in that base. What is the number 43 if 8 into 8 is 54? Like, if the system that we are using, that is base 12, then what is the number 43? So that means 43 is in base 12. I need to shift it or convert it to base 10. Right? Or I should just know the number. So, now place value. This place value is 12 raised by 0. This place value is 12 raised to power 1. So number is 4 into 12 raised to power 1, which is 12, plus 3 into 12 raised to power 0, which is 1. So this is 48 plus 3, that is 51, which is the answer. Alright, on to the next one. He says let PQR be a triangle right angled at P. So let me make my triangle. So this is PQR. If S and T trisect the hypotenuse QR, right? Trisect, so 3 equal parts. So suppose this is X and this is T. Now trisection, that means QS is equal to ST is equal to TR, right? And 9PS square plus 9PT square is equal to MQR square. Then write the value of M, right? So basically I need to relate PS square, PT square and QR square. First of all, squared quantities are getting involved. That means definitely what should be used? Pythagoras theorem, right? Now, PS. So let me just join PS first and PT as well. Now, PS I need. PS square I need. That means I need a right triangle. Can you see a right triangle where PS is the side? Absolutely not. That means you need a right triangle. That means you need to drop a perpendicular. Now, you want PS as the side of the right triangle. So what I'll do is, I will drop a perpendicular from P. Let this point be U, right? As you can see, PUS is a right triangle and I can get PS square. Similarly, PUT is a right triangle and I can get PT square, right? So let me just try to write out. Now, PU square will be used again and again. I don't like saying PU again and again. So let me just write H, right? Also, I need to make use of the fact that this length is equal to this length is equal to this length. So let me call this length X. This length is also X. And this length is also X, right? Now, if I want to write PS square, obviously this thing would be getting involved. So let me name this Y. And this thing has to be get involved. So this is Z. I know that Y plus Z is equal to X. Don't forget that, right? So let me write PS square. So 9 into PS square is nothing but H square plus Y square. Plus 9 PT square. So PT square is nothing but H square plus Z square. Plus Z square. Is equal to, obviously I need to write in terms of QR square. QR square is nothing but 3x whole square, which is 9x square. So M into 9x square. So what I'll do is, I will try to reduce everything here in the form of X. Now how can I do that? First of all, H is here. H is here. How can I relate this altitude to the hypotenuse, right? You might say triangle, area of the triangle might be getting involved, but area of triangle, I don't know anything about PQ and PR. So how else will I relate this length, which is the altitude, to the hypotenuse? Now, obviously the sensible thing is go for similarity, and we have done this question quite a lot in class 10, in which we arrived on this theorem, which was H square is equal to product of these two parts. So X plus Z into this, which is X plus Y. You can easily prove this by similarity of triangles, right? So that means instead of H square, you can write this, right? And once you open it up, you basically will get 9x square plus 9 into x square plus y square plus z square plus 2xy plus 2yz plus 2zx. You'll get this, which is equal to m into 9x square. Right? As you can see, this is nothing but x plus y plus z whole square. Mind it, y plus z is x. So substitute, because I want to convert everything into x. So x plus x, which is 2x, 2x whole square, which is 4x square. And 9 is also multiplied here. Don't forget that. So 9x square. Just substitute, not substitute, you will get the answer easily. M will turn out to be 5, but you will write the answer as 0, 5. Alright, on to the next one. Now this was one question which was quite easy. So let's just quickly discuss it. Now he says let n be an integer equal to this. So this is nothing but 1 followed by how many zeros? 29 zeros. So 0, 0, 0, so on, 0, 0. So these are 29 in number. Right? Minus 30, so subtract 30. Right? So subtract it. So here I'll get 0. Then obviously I will carry forward, so this becomes 7. Then it becomes 9, 9, 9, so on. I'll get it 9. Right? Now, he says let sum of digits of n is k. So this is my n now. I want sum of the digits. So I need to basically evaluate how many 9s will come. Right? So let me see. 9 comes from here and here. Right? 29 zeros were there. 2 I rejected, so that means 27 zeros are there, 27 9s are there. So 27 9s. That's it. So add 9 27 times plus 7, which will give you the answer, and k by 10 turns out to be 25. Right. On to the next one. He says write the number of subsets of this set that have no two successive numbers. No two successive numbers. That means if 1 is there, 2 cannot be there. That means if 4 is there, 5 cannot be there. Right? So write the number of subsets. So any subset of this set can have 1 element, maybe it can have 2 elements, 3 elements, 4 elements, so on. So let me make my cases on the number of elements in the subset. Right? First of all, let me write 1 element subset. Now, if I take the subset that is just 1, do you think this set satisfies the property? Now, the property is no two successive numbers should be there. You can see no two successive numbers can be there. So, that means this is one such subset. Another can be set containing 2, set containing 3, then 4, 5, 6, 7. So, 1 element subset you would have 7 in number. Next, I'll make the case on the basis of 2 elements. Right? So maybe I can have a set where I have 1 and 2 I cannot have 3. So just check whether set containing 1, 3 satisfies the property or not. Yes. No two successive numbers are there. Right? So 1, 3 is such. Then 1, 4 would be there. 1, 5 would be there. 1, 6 would be there. Now 1, 7 would be there. I've exhausted all the subsets which have 1. Then let me move on to 2. So 2 is there. 3 cannot be there. So 2, 4 can be there. 2, 5. 2, 6, 2, 7, and so on. Right? You can write the 2 element subset. Then you will come on to 3 element subset. Then you will come on to the 4 element subset. In fact, in 4 element subset, there would be just one set, that is 1, 3, 5, 7. Right? You'll realize it by just make it. Now, the question is, are we forgetting something? He says, write the number of subsets. I have taken 1 element, 2 elements, 3 elements, 4 elements. And the further ones cannot be found. Now, empty set is a subset of every set, right? So that means empty set would be the subset of this one. Now, do you think empty sets satisfy the property or not? So this is my empty set. Now, do you think it has successive 2 numbers? Absolutely not. So no 2 successive numbers are there in this set. So that means automatically this also satisfies the property. So you add this set as well. So this, number of this, number of this, number of this, number of this, the answer will turn out to be 34. Alright, on to the next one. If k is the number of integral solutions of this equation, then write the sum of digits of k. So in short, I need to ascertain what k is. Right? He says number of integral solutions of this. Right? So first of all, mod of some quantity or mod absolute value of some quantity is less than 2033. That means this number, as in mod of x minus 2022. This number lies between what? 2033 and I should say minus 2033 and 2033. Right? Because this number, absolute value of this number is less than that. So that means this number lies between minus of this and plus of this. Right? So obviously I'll be adding 2022 on the 3 sides. So I will get minus 11, I guess. Right? Minus 11 less than mod of x less than 4055. Right? Now mod of x lies between this and this. Now mod of x is what? It is a positive quantity, right? So that means I can say it has to be 0. It has to start with 0. Now can mod of x be 0? Yes. So 0 less than equal to mod of x less than 4055. Right? Now I need the integral solutions. That means mod of x will also be an integer. So that means it can be 0. Mod of x can be 0, that will give me x equal to 0 as the solution. That is just 1. Right? Then mod of x can be equal to 1. Right? Here I can get x equal to plus minus 1. Two solutions I am getting. Two integral solutions. Then mod of x equal to 2. That means x can be equal to plus minus 2. And again I'll get two solutions. Now so on, you can say mod of x equal to 3. That will give me x equal to plus minus 3. That means two solutions again. And so on. This process continues. I'll get mod of x equal to, now less than 4055. That means the integer less than this one. So that is 4054. Right? Again you will get two solutions. Just add this number and you'll get the answer for k, and sum of digits of k turns out to be 18, which is the answer. Alright, next one. The geometric sequence, as in geometric progression with n terms, is this. And it has T1 into Tn is equal to 3. That means this into this is equal to 3. Also the product of all n terms equals this. That means T1 into T2 into T3 into so on into Tn, that is given to be 59049. He says write the value of n. Also for the lower classes we have given the definition of geometric sequence also, but I am not reading that because we very know what geometrical progression is. Right? Now I need to use the fact that T1 into Tn is equal to 3. Product of first term and last term is given to be 3. And it is the geometric progression. Product of first and last. Now geometric progression is very nice. Why? Because if this is my geometric progression, I'll multiply a constant term and I'll get this one. Multiply a constant term, I'll get this one. Now if I go here, I'm multiplying by a constant term. Now if I move backwards, I'll divide by the constant term. I'll divide by the constant term. That means if I move here, I'm dividing by a constant term. That is why what happens, if I take product of this and this, and product of this and this, these two turns out to be same. In fact, product of first and last, product of second and second last, product of third and third last, they are all the same. That is the property of geometric progression. Right? Okay. So that means if I multiply T1 and Tn, so that means I need to multiply T1 and Tn. So let me write a T1, Tn over here. And T2, I need Tn minus 1. For T3, I want Tn minus 2. And so on. For Tn, I need T1 again. Now, mind it, I have written this in the reverse order. So this product will also be 59049. What is the benefit for this? I know that this product is 3, this product is 3, this product is 3, this product is 3, and so on. So basically 3 into 3 into 3 into 3 into 3. How many times 3 occurs? N pairs are there, so 3 raised power n is equal to 59049 whole square. Right? Obviously, this thing is 243 square, I think. 243 square. So you can find the value of n. N turns out to be 20. Alright, on to the next one. He says write the number of pairs a comma b of positive integers for which this equation is satisfied. Which equation? A cube plus 2ab is equal to 2013. Right? A comma b and both are positive integers. This is a positive integer, this is a positive integer. Right? And I need the number of solutions basically. Now, mind it, here I have a cube and here I have 2013. This is a very small number because you know when we cube the numbers, it becomes very large very quickly. Right? So, let me think. Now, a is a positive integer, that means a, the minimum value of a which is possible, that is 1. Right? So, 1 plus 2 into 1 into b is equal to 2013. Right? That means when a is equal to 1, I will get some natural value of b. Why? Because this is 2012 divided by 2, that is 1006. So 1 comma 1006 is one such ordered pair. Right? Then you can take a as 2. You will not get a solution here because I want a to be a natural number. Then a can be 3 and so on. Now you are saying, so what values do I have to check? Mind that this is 2013. I know that a, if I take a as 10, that 10 cube is 1000, okay. If that means 10, 10 पे जाऊंगी. Then A cube 11. If A is 11, 11 cube is 1331. Less than this, I can take A as 11. I can take A as 12 as well because that is 1728. But I cannot take A is equal to 13 because 13 cube is definitely greater than this one. Right? So in all, I just need to check what? From 1 to 12, just 12 possibilities. Right? That will hardly take any time. That is why the answer is 0, 3. Alright, on to the next one. He says factorize this polynomial into two quadratic factors with integral coefficients and leading coefficient equal to 1. Okay. Write the sum of squares of the coefficients of the linear terms of the quadratic factors. Now he is talking about the linear terms of the quadratic factors. If I can guess the quadratic factors, I can find the answer. Right? Now I need to factorize this. X raised to power 4 plus 11x cubed plus 14x squared plus 13x minus 21 into two quadratic factors. And leading coefficient is 1. Right? So that means here if I have x squared, here I will have x squared. Mind that the quadratic factors have integral coefficients. Right? So whatever the case may be, these coefficients have to be integers. Now, mind it, coefficients integer. Now you can say, ma'am, write plus ax plus b, then plus cx plus d. Wait a second. I know that integral coefficients are there and the constant term is minus 21. Right? So, if the constant term is minus 21, here possibilities are what? I can write plus 1, minus 21. Right? Because I can write minus 21 as product of 1 and minus 21. Right? So, here, then I can take my linear term to be ax and the linear term to be bx. I've reduced my number of variables because solving linear equations in 4 variables will be a little bit complicated. Right? Now, and it might not be solved, that is also the case. Right? So, this is a polynomial, left hand side is a polynomial, right hand side is a polynomial. Right? You'll compare the coefficients and you will try to get the value of A and B. Now, what will happen when you try to compare the coefficients? You will get 3 equations. Why? Because you will compare the coefficient of x cubed, you will compare the coefficient of x squared, you will compare the coefficient of x. Right? Actually, let's try to do that. So, coefficient of x cubed, here obviously it is 11 and here I can write the b plus a, so that is a plus b. Right? Coefficient of x square, here it is 14 and here the coefficient of x square is minus 21 plus ab plus 1. Right? So, this is minus 20 basically. Minus 20. So, basically, AB turns out to be 34. Right? And last, coefficient of x, here it is 13, which is equal to minus 21A plus B. Right? Now, you can see that this is a linear equation in 2 variables. This is a linear equation in 2 variables. You can solve it and get the value of A and B. But, mind it, all the 3 equations have to be satisfied. So, whatever value of A and B you get, you have to check whether this equation is satisfied or not. In fact, for this case, it will not be satisfied. What does that mean? If you cannot find the value of A and B, that means your breakup of constant term is not correct. But it's fine, it's fine. So, you can check 1 and minus 21, you can check for minus 1 and plus 21, which you can see is also not the case because rearrange the terms here, you will realize that is not the case. Now, 21, 1 and 21, what are the factors? 3 and 7. So, I can do plus 3 and minus 7. I think for this, you will get the answer. Compare the coefficients, get the value of A and B and check whether the third equation is satisfied or not. That means you will get the answer for A and B. You can write this sum of the squares of coefficients of linear terms. That means you need to write sum of the squares. So, A squared plus B squared, you need to write this. This answer turns out to be 85. So, if you have a biquadratic polynomial, you need to factorize into quadratic factors of integral coefficients. This method of factorization can be used. Because as you can see, I am unable to guess straight away what can be the roots of this and unable to guess or observe any kind of factorization technique. But this technique is also very important when you suppose the quadratic factors. Alright, on to the next one. Now he says Lena Lair, the CEO of Chanel, conducts her business in the following manner. Every once in a while, she increases the price of a handbag by X%. Right? Then A while later, she reduces all the new prices by X%. So she increases the price by X% and reduces the price by X%. After one such up-down cycle, the price of the handbag is decreased by 2,500 rupees, right? And after second such up-down cycle, the handbag is sold for rupees 57,600. Write the value of X, right? Now what she does, she increases the price of her handbag by X%. So obviously I have no idea what the price of the handbag is. So let me suppose my price of the handbag to be P, rupees P. Now she increases the price by X%. So that means P plus X% of P. Right? This is the new price. New price. Now X%, that means X by 100. Now I can take obviously P common, so I can get 1 plus X by 100. Now what she does, then a while later she reduces all the prices by X%. Now her price is this, and she reduces by X%. So new, I should say more new basically, what she does is she reduces the price by X%. Right, so reduces. So I have my price this 1 P into 1 plus X by 100. I need to reduce it by X%, so minus X% of P into 1 plus X by 100. X% of this price, which is this one. Right, now X% is nothing but X by 100. Now as you can see, I can take P into 1 plus X by 100 common. I'll be left with 1 minus X by 100. This is the new price. And this is the end of one such cycle. Now he says after one such up-down cycle, this has happened, the price of the handbag is reduced by 2,500. So the price earlier was what? P. Now it has been decreased by 2,500. So that means earlier it was this. New price is this. It is decreased. So that means old minus new is equal to 2,500. This is one such equation. Right? Okay. Now he says after second such up-down cycle, right? So what happened? After the first up-down cycle, my price was what? How much? This thing? Basically, P into 1 plus X by 100 into 1 minus X by 100. Remember, because we took that common out, right? This happens after one such cycle. Now what will happen? X% increase. So plus X% of this. As you can see, फिर से वो चीज आ जाएगी. Basically, you will multiply by 1 plus X by 100. Do it yourself. You can find out. It will turn out to be this. Now, decreases by X%. You will realize that the factor will be 1 minus X by 100. Right. So after second cycle, what will happen? P into 1 plus X by 100 whole square. Right. And 1 minus X by 100 whole square. This is the price of the handbag after second up-down cycle. And the handbag is now sold. So that means this is equal to 57,600. This is the second such equation. Right? You need to find the value of X. That means you don't want P. As you can see, P you can take common out here. P is there. You can divide the equations, get the value of X, and it will turn out to be 20. Alright. So the next one. A multiplicative partition of a positive integer n greater than or equal to 2 is the way of writing n as product of one or more integers. Right? Way of writing product of one or more integers, each greater than 1. Note that we consider positive integer to be a multiplicative partition of itself. That means if I have the number 25, the multiplicative partition 25 would also be there. Right? Also, the order of the factors does not matter. Suppose in a multiplicative partition, 2 into 3 into 5 is there, and 3 into 2 into 5 is there. Now, order does not matter. These are considered to be same. Right? For each positive integer n greater than or equal to 2, define P of n to be the number of partitions possible. Right? Okay, P of n. So, P of 40 is given to you, which is equal to 7. That means number of partitions. That means number of ways of writing 40 as product of one or more integer, that is 7. And he has given that. First one is 40. Right? Second is 2 into 20. Then 4 into 10. Then 5 into 8. Then 2 into 2 into 10, 2 into 4 into 5, then 2 into 2 into 2 into 5. So you can see that these are 7 in number. So basically you need to write 40 as product of one or more terms. So one product of just one term, product of two terms, product of two, product of two, product of three, product of three, product of 4. In fact, if you notice, he has already given us how to count the cases, right? Our question is write P of 800. That means you need to count in how many different ways can you write 800 as product of numbers. So my number is 8 now, 800. Right? So let me try to write it. So obviously 800 may the multiplicative partition would have 800. Then you can see first I'll write all the product of two numbers, right? That means ways in which I can express 800 as product of two numbers. So I can start, that is 2 into 400. Then I can have 4 into 200. Then I can have 5 into 160. Then obviously 6, 7, no, 8, yes, 8 into 100. Then I can have 10 into 80. Then I can have 16 into 20, 16 into 10, no, 16 into 50, of course, right? Then I can have 20 into 40, right? Then I can have 25 into 32, and then I will start repeating it, right? Because 32 into 25, again, ordering does not matter, so I've already written it. So first I wrote product of one term, that is this. Then I wrote product of two terms. Then I can go for product of three terms. Product of three terms, so I can write 2 into 2 into 200, right? Maybe then product of 3. So then I can write 2 into 4. I can take 2 from here. 4 into 100. Then I can take 2 into just 3. 3 you need to write it, right? So 2 I can take. So 8 into 50 and so on. In this way you have to write each and every case. Right? Now you know that the answer lies between 0 and 99. That means there cannot be more cases than 99. Right? Because he directly asks you the number. Right? So provided you have the concentration, provided you do not miss anyone, provided you do not over calculate, because sometimes you count the cases twice. Provided you don't do that, you will get the answer as 47. You know the method, just write down product of two numbers, product of three numbers, product of four numbers, product of five numbers, and so on. Alright, on to the next one. Line segments AC and DF are tangents to the circle at B and E. You can see tangents. If also AF intersects the circle at P and R and intersects BE at Q, right? If angle CE, CAF, so that means this angle is given to be 40 degree. And DFA, so that means this tiny angle, that is 30. And FPE, where is F? FPE, that means this angle, that is equal to be 25. I am interested in PQ, PEQ, that means this angle. Right, this tiny angle I am interested in. Now, obviously since tangents are given, that means I will locate my center, maybe it is here. And if I join the point of contact with the center, I know that this angle is 90. And if I join this, I know that this entire angle is 90 degrees. Right? Now, let me just try to write all the angles that I can figure it out. Now, mind it, this angle is 90, so this is 90. So, move to this triangle. FE, I don't know this, maybe we can use it F. FES triangle. This is 90, this is 30. That means this angle is 60 degrees. Right? Alright. What else? I found out one angle, which is this one. Now, this is the vertically opposite angle, so that means this is 60. Right? What else do I know? Now, mind it, if I consider this quadrilateral, OSAB. Can you see this quadrilateral? OSAB. Now, it is a quadrilateral, that means sum, as in this, plus this, plus this, plus this, that is 360. Now, this is 60, this is 40, this is 90. I can find out this angle, that turns out to be 170. Right? Mind it, I have to go to this tiny triangle. Okay, tiny angle, not triangle. Tiny angle. How should I go? How should I move on? Now, consider this triangle, OEB. Triangle OEB. Can you find out some other angle? I think you can. In this triangle, OEB, OE is equal to OB, right? It is an isosceles triangle. This is 170. That means this angle plus this angle, this one. These two angles, the sum is what? That is 10 degrees. So each will be 5. So that means this is 5 degrees and this angle, this is 5. Right? Okay. Now, which angle? Maybe I should write it here. Angle BES, that is 5 degrees. This is it. Right? I am interested in this angle, this one. Now, move to this triangle, triangle CES. Let me make it for you so that it is easier. Triangle CES. So, I know that this is S, this is P, this is E. This angle is 60 degrees. I am recreating it. And I am interested in this angle, EQR. So, I am interested in this angle. I already know that this is 5. And this is 25, which I have not used till now. Mind it, this, as you can see, is the exterior angle of triangle CES. Exterior angle is equal to sum of this and this. This is 60, this is 25, so that means this is 35. This entire angle. Out of this entire angle, this is 5. That means this angle is 30 degrees, which is angle PEQ. That is why the answer is 30. Alright, on to the next one. He says let K be the second smallest number with exactly 28 divisors. Second smallest number with exactly 28 divisors. Write the sum of digits of K. Basically, I need to find the value of K. Right? Now, mind you, he says exactly 28 divisors. So, if I have any number, right, suppose that is K, or maybe N you can take, any number you can take it, right, I can factorize it, prime factorize it, so it may be P1, which is a prime number raised by something, so A1, into P2 raised by A2, into P3 raised by A3, right, and so on. If I say, write the number of divisors of N, how do we find that out? We find that out as A1 plus 1, into A2 plus 1, into A3 plus 1, and so on. This is how we find the number of divisors, right? Now he says that it has exactly 28 divisors. That means 28 will be expressed as product of some numbers, right? And product of some natural numbers only, right? So first case that can be, I can write 28 as 1 into 28. Right? Now, if 1 and 28 is there, this is how I've written 28 as. Right? What can be the number? Mind it, I need to take the second smallest number, right? I need to take the smallest number, second dekh lenge, right? So that means I'll be using the smallest prime number available to me, which is 2. Right? In that order, I will use it. Right? So I can write this as, if I write the number 2 raised by 27, this number would have exactly 28 divisors. Why? Because 27 plus 1, 28. Into 1, you'll get 28. Right? Obviously, this is a very big number. I need the second smallest one. Right? 1 into 28. So, this is done. Now, I can write 28 as product of two numbers. 1 into 28 ho gaya. So, next I can take 2 into 14. Right? That means I can take the power of 2 as 13. And then, since I want another prime number, I'll take the second smallest one, which is 3 into 3. Right? Obviously, you can see 14 into 2, 28 divisors. Done? Okay. Then I can write 28 as 4 into 7. That I can write as 2 raised by 6 into 3 cube. Right? 7 into 4, you can see number of divisors is 28. Right? Obviously, out of these 3, this is the smallest one till now. Right? How else? Now, 28 can be written as product of two numbers. Now, 28 can be written as product of 3 numbers as well. Right? So, maybe I can have 2, then I'll take 2, and then I'll take 7. Right? So, corresponding to this, I'll get 2 raised power 6 into 3 raised power 1 into 5 raised power 1. Because I need to involve another prime factor, so obviously I went with 5. Right? Check the number of divisors, 7 into 2 into 2, which is 28. Right? Okay. Now, is there any other way of writing 28 as product of 3 quantities? Actually, you cannot, right? Because 2 to 7, you have already written prime factorization, you cannot factorize it further, right? So this is the case. Now, if I calculate, look at this, because out of those 3, it was this one which was least, and look at this. Now, obviously, you can see this is 64 into 27, this is 64 into 15, that means this is the lesser quantity, lesser number, and this turns out to be 960. But my question is not about the smallest number. My question is about the second smallest number, right? Second smallest, that means I need to increase it slightly. Now, instead of 5, maybe you can take the next prime number. So, 2 raised to power 6 as it is into 3 raised to power 1 into 7 raised to power 1. Again, you can see 64 into 21 will be less than that one, right? I slightly increase because instead of 5, I am taking 7. So, this must be the second smallest number, and I think this turns out to be 1344. Right? You need to write the sum of the digits, which turn out to be 12, which is the prime number. Next one, solve in real numbers the system of equations. So, a plus b is equal to 8, ab plus c plus d is equal to 23, ad plus bc equal to 28, cd is equal to 12, where conditions are there, a is not equal to b, c is greater than d. And if a, b, c, d is such a solution, you need to find the value of c. Now, the easiest method is, now as you can see, all of these are integers. So, let me look for the integral solutions first. Right? Makes sense? Now, here it is given that CD is equal to 12. Right? CD is equal to 12. So, that means I need to write 12 as product of 2 integers. I can write that as 12 into 1. Right? One such case. That means you will take C to be 12 and D is equal to 1. Then try to find the corresponding values of A, B, C and D and see whether all the conditions, all the equations are satisfied. In this case, it will not be. Right? Don't worry, it's fine. 12 into 1 does not work. Go for 6 into 2. Take C to be 6 and D is equal to 2. Solve it, check whether all the 4 equations are satisfied or not. And to your surprise, you'll find that this is satisfied. So C will turn out to be 6. That is why the answer is 0, 6. This was the very first thing that you could have done. Why? Because hit and trial is a very good method. And since integers were getting involved, there might have been integral solutions. Just find them out. Right? But let's try to understand some method as well. How will we find the solution of these system of equations? Now, if you look carefully, I have AB plus B is equal to 8. AB plus C plus D is equal to 23. AD plus BC equal to 28 and CD is equal to 12. These 4 equations are there. Now, try to find out where do these terms occur. Right? Maybe in some factorizing polynomial I should say, these 4 expressions will occur. Now, how should I make use of that? Now, mind it, A plus B is there, right? And CD is there. A plus B is there and CD is there. Let me consider 2 quadratic factors. So, x square plus ax plus c. And the other I'll take x square plus bx plus d. Can you see that A plus B occurs in this and CD also occurs in this? Right? Let me just open this up. So, x raised to power 4 plus coefficient of x cube. That will be what? A plus B into x cube plus. Now, coefficient of x square I'll write. Coefficient of x square. So, that is D plus AB plus C. AB plus C plus D. There might not be a coincidence here. So, something is happening. Plus. Now, coefficient of x I'll write, which is AD, right? AD plus BC. AD plus BC. Okay. And obviously, the last term would be CD. You were able to write 2 factors in which these 4 expressions occur. right? Because come on, A plus B is there. A plus B is there. That means I can have a factorization. A you'll pick up from here and B you'll pick up from here. That means you'll keep A and B in separate factors. Right? Now the question is, what is benefit of this? I think it is quite beneficial. Why? Because I know this, I know this, I know this, and I know this. So basically this becomes a polynomial x raised to power 4 plus 8x cubed plus 23x squared plus 28x plus 12. This is a very nice polynomial. Why? Because this is easily factorizable. Minus 1 is the root. I should say 0. Minus 1 is the 0. Minus 2 is the 0. Minus 3 is the 0. This can be written as x plus 1 into x plus 2 into x plus 2 into x plus 3. Why I have written like this? Why? Because I am interested in the values of A, B, C and D. Cool? So, let me see. Let me write this as now x square plus ax plus c into x square plus, in fact, let me just erase this and I'll get it. X square plus ax plus c into x square plus bx plus d. Right? If I want to find out this quadratic factor, maybe I can multiply these two. Right? And obviously this quadratic factor will be available when I multiply these two. Right? So this is either is equal to x square plus 3x plus 2 and this is equal to x square plus 5x plus 6. Right? This is one of the cases. I am writing down all the solutions. Even though my answer is already there, I am writing down all the solutions because that is how we learn currently. Right. Okay. What else? Okay. Right. So these two I multiplied. What I can do is, if I multiply these two and these two, that is one of the same thing, right? Okay. Now, what else can I do? Then, next I can do is, I can multiply these two and multiply these two. So, x square plus ax plus c, this into this, that is x square plus 4x plus 3 and this into this, that is x square plus 4x plus 4. Right? Obviously, another thing what can be, these are the two things but can be repeated. So, this is x square plus 5x plus 6. This one, these can be interchanged and corresponding x square plus 3x plus 2. And one case would be, I don't have a space here, so maybe I can write here. X square plus 4x plus 4 and x square plus 4x plus 3. Right? In each of these cases, you will get the ordered quadruple, which are the solutions for the equation. Our aim was just to find one solution, but this is how you solve the equation, system of equations, if number of solutions were asked. In fact, they asked the same question in a very different form in the previous year mock test. So, if you were unable to solve this question, that means we are not doing previous year papers, which obviously is not great. Alright, on to the next one. The base of an isosceles trapezium are equal to 21 and 9. And the altitude is 8. Right? Isosceles trapezium I know. So, let me make it. Right? So, this is 21. This is 9. And isosceles trapezium, that means this is equal to this. Right? Okay. And altitude is 8. So, that means this length is 8. Okay? Right. Now, he says, let R be the radius of the circumscribed circle. Okay. So, I should have a circumscribed circle, which looks something like this. Somewhat, yeah, it looks like a circle, definitely. So, R is the radius of this circumscribed circle. I need to write the value of 8R. So, basically, I need the radius, right? Radius of the circle. Now, radius, that means I need to take center. Now, you can see that this is the chord of the circle, right? If I drop a perpendicular, it will bisect the chord, right? So, entire is 21, this is 21 by 2. This is 21 by 2. Also, if I extend it, since these two lines are parallel, this is 90, this is also 90. Now, this is a perpendicular from center. That means it will bisect this chord as well. So, this is 9 by 2. This is 9 by 2. Now, I am interested in the radius. So, that means I am interested in this line. I have to use the altitude, which is 8. Right? So, let this length be R. right? Let this length be x. I don't know this length because I have to use this one. Now, if this is 8, this is x, this length is 8 minus x, right? Also, if I join this is also radius. Can I say that I can apply Pythagoras theorem in OAB in this triangle, then in triangle OCD, right? I can say that r square, which is x square plus 9 by 2 whole square, right? From here I can write r square, from here I can write r square, which is 8 minus x whole square plus 21 by 2 whole square. You can find the value of x square and automatically you can find the value of r square. And then you can find the value of r. Ultimately, the answer turns out to be 23rd, right? The answer turns out to be 85. Alright, on to the next one. An inverted right circular cone of height 25 centimeter is filled with oil up to half of its height. First of all, I am talking about the inverted cone. So it looks something like this. It is half filled with oil. This looks like an inverted cone? Yes. First of all, height is 25. Half filled is filled with water up to half its height. So this is my oil. And suppose this height has to be 25 by 2. Right, the oil is dripping from a hole in the tip, so obviously oil is leaking out from here, as you can see. Initially, the upper surface area of the oil, upper surface area, where is the oil? Oil is here. What is the upper surface area? Oil is here, upper surface area is this one. This area is given to be what? 154 centimeters square. Right, okay, let's move on. Now he says after 49 minutes, since the oil is coming out, the height of the oil becomes half of its original height. So after 49 minutes, half of its original one. So now my oil is here. Right? This height is 25 by 4. Why? Half of this. That is 25 by 4. And now he says the upper surface area. So oil is here, upper surface area is this one. This is how much? This is 77 by 2. And this all happens in 49 minutes. Now what happens? Oil from a cylindrical beaker of diameter this and height this is poured into the cone. In how many more minutes will the cone be emptied out? Right? Now, if I need to empty out the cone, I need to empty out this oil which is left and the additional oil that I poured. Right? Okay. Now what do I know? That what happened? The oil which leaked out, which is this one, in 49 minutes. So, how much volume of oil dripped out in 49 minutes? Let me find out. So, this is the volume of the oil, right? This is nothing but the volume of the bigger cone minus volume of this red cone, right? The volume of the bigger cone. So, I know that is 1 by 3 pi r square h. Now, pi r square, because this is the area of the circle which is given to you, that is 154, right? Into h, height is 25 by 2 minus the volume of the smaller cone, which is 1 by 3 into. Now, this area is already given, so 77 by 2 into the height, which is 25 by 4. Right? This much volume was dripped out, or it was let out in 49 minutes. Right? Now, how much volume has to go in order to empty out the cone? First of all, this much volume. So, this is what? Volume of this cone, which is nothing but 1 by 3 into 77 by 2 into 25 by 4. Right? Plus the additional oil that I poured from the cylindrical beaker. Now, volume of the oil in the cylinder would be equal to the volume of the cylinder. So, plus additional oil that I need to empty it out. Volume of the cylinder, which is pi, 22 by 7, into r, which is diameter is 3.5, r is 3.5 by 2, r square, so 3.5 by 2 again, into height, which is 25. Right? Now, it took 49 minutes to empty out this. I need to empty out this much of water, oil, right? So, as you can see, this and this, they are directly proportional, right? This and this, they will be directly proportional, right? Or I can say, this is in direct variation or this is in direct variation. So, this thing divided by this is equal to this time I need to find out. This by this is equal to this by this. You can see the rate at which it is being emptied out is uniform. That is why I am saying it is in direct variation. Right? So you can find out, you can consider this to be x. You just need to divide it. You are brilliant at calculation, hopefully. And the answer turns out to be 28. Alright, on to the next question. Triangle ABC is right angled at B. So let me make my triangle. B is here, obviously, because 90 is here, and AB is here, A is here, and C is here. Now he says P and R lies on AB. So here, so that BR is equal to 6. BR, so suppose BR is this is 6, and BP is 10. So this is P maybe, and this is 10. Right? Now he says that BC is 8, this entire length is 8. And area of triangle QRC, where Q lies on AC, and PQ is parallel to PC. So make a parallel line, right? This has to be Q. Then he says area of triangle QRC. So this triangle he says. This area is given to me, that is equal to 20. Right? Now he says find AP, so that means I am interested in this length. Let me say that this is X. I am interested in the value X. Now, mind this, area is being used, right? Area is being used, and this is 90, that means I can find the area of this triangle. And obviously, this is 90, so for this triangle, altitude is there and base I can see. So, I'll write all the areas that is available to us. So, area of this triangle, which is half, base is maybe 6, and height is 8, plus 20. Plus area of this triangle half, base is this much, now this much, this is x, now this much is how much, this is 10, this is 6, so this is 4, so this base is 4 plus x, into height, I don't know the height, right, so let me just write it as h, we'll see whether there is a relationship between h and x, so into h, so you can see area of this plus area of this plus area of this is equal to the entire area, and this is a big right angle triangle. So this is equal to half. Base I can take this one, so 10 plus x, and height is given to me, which is BC, into 8. Right? So I have an equation in h and x. So I need to write another equation relating h and x so that I can have two equations I can solve and get the value of x. Now, h and x, what else can I use? Now, can I see h is getting involved here, x is getting involved here, right? This tiny triangle is similar to the big one, right? We can see that. Now, when I say that the triangle QPA is similar to triangle CPA, it's a very commonsensical thing, right? So, can I say that h by this, so h by 8 is equal to this by this, so x by 10 plus x. A relation in h and x, you can find the value of x, which turns out to be 25th. 2, that is why your answer is 0, 2. Alright, on to the next one. He says a 3-digit number is equal to arithmetic mean of all numbers obtained from the given number with the aid of all possible permutations of its digits. Okay, too long a sentence. Let's see. He says a 3-digit number is equal to arithmetic mean of all numbers obtained from the given number. So any given number is there, and I need to obtain all the number with the aid of all possible permutations of the digits. Right? So obviously 3 digits would be there, and all the possible permutations which are possible. I will add them up and divide by 6, because that will give me, why divide by 6? Because permutations. Okay, divide by the number of permutations. We'll get down to that. Divide by the number of permutations. That will give me the arithmetic mean, and that should be equal to the number itself. Right? And he says this includes the identity permutation. That means the number itself also I need to take in the permutation. Right? He says write the number of 3-digit numbers possessing this property. Right? 3-digit numbers. Now, if you look carefully, I can probably write 9 such numbers like this itself. Right? Just think about it. 3 number 3-digit numbers whose permutations I can quickly see. 111. What are the permutations possible? 111, 111. This is the only permutation possible, right? So just one permutation is possible, so the number itself. So 111 is obviously equal to 111, right? Then I can say 222, then 333, then so on. I can say 999. These 9 numbers, this should have been visible to you, right? These are the 3-digit numbers that satisfy the property. But the question is, are these the only 3-digit numbers, or are there more? There might be, so that is why we need to be a little bit careful. Right? Now, I am talking about the 3-digit number. So, 3-digit number. So, let my digits be A, B, and C. Right? Now, if I write this in the expanded form, I will have 100A plus 10B plus C. Now, he says that this number should be equal to the arithmetic mean of all the numbers obtained with the aid of all the permutations possible. Now, what are the permutations possible? First is obviously ABC only. Other permutations ACB. Then exhausted is A, so BAC. Then BCA. Then CAB. Then CBA. I've exhausted all the permutations. Now, he says the number is equal to arithmetic mean of this. That means this plus this plus this plus. Now, don't add this. Expanded form. Careful. Expanded form. Second, 100A plus 10B plus C. Expanded form. 100A plus 10C plus B. Then expanded form. 100B plus 10A plus C. You know what are the expanded forms. So, I need to add all these numbers and divide by 6. So, अब add करना है numbers को. तुम्हें पता है यहाँ पे A. 100 place पे twice. 10th place पे twice. And unit place पे twice. So, 200 plus 20 plus 2. That is 222A. Plus, same will go with 222 with B plus 222 with C. Whole divided by, because I've added all the numbers, arithmetic mean चाहिए, so I'll divide by how many permutations are there, that is 6. This should be equal to the number itself. So 100A plus 10B plus C. Right? Obviously, I'll cancel out the factors, cross multiply. Ultimately, I'll get 7A is equal to 3B plus 4C. This is the equation that will I get. Right? Mind it that A, B, C, they are digits. Right? They are digits. That means they might vary from 0 to 9. Right? Yes, A cannot be 0, but it's okay. Rest of them, B and C can be 0. So that is okay. Right? So let's just start exhausting it. So B, the least value of B that can be possible, that is 0. Right? And this is, I need 7 into it. So what I can do is, I cannot take C as 1 because that is 4. 4 is definitely not a multiple of 7. Then I cannot take 2. 4 into 2, no. 4 into 3, no. 4 into 4, no. 4 into 5, no. 4 into 6, no. 4 into 7, yes, that is a multiple of 7. So I can take C as 7. Correspondingly, I get A as 4. So 407 is one such number. You can check it out, right? 407 is one such number. You can write all the permutations. So 407 first, 470, then 704, 740, and permutation 047, 074. Add them up, divide by 6, you'll find that it is equal to this itself. Right? Okay, so we've got one such number. So 407, now I can put B as 1, then I can put C as 1, and I can get A as 1. Then I can put A as 1, then I'll put C as 2 and see whether I'll get it or not. So basically 3 plus 4 is okay because I get 7. 3 plus 8 is not okay because I get 11, not a multiple of 7. Then plus 12, 15, not a multiple of 7, so I don't like it. 16, 19 ho jayega, not a multiple 11. 3 plus 20, not a multiple of 7. Okay. 24 plus 3, 27, not a multiple of 7. Then 28, 3 plus 28, 31, no. Then 35. Ooh. 35. I get one more. 35 I get, right? So if I take B as 1 and 4 as 8. 32 plus 3, that is 5. I'll get A as 5. So in this manner, you can exhaust it and probably if I have not made a mistake, 3 plus 32. Yeah. I'll get 1, right? So then you can take B as 2. You'll obviously find 2 that case because we arrived at that. Exhaust all the cases, you have to, because if you want the correct answer, you need to. But it's not that much. I think you can do it. Just do it like this. It hardly takes 10 seconds to do that. Okay, 30 seconds. Fine. Right. You can find out the total number of numbers, and the answer turns out to be 50. All right. On the next one, a computer manufacturing company purchases components A and B from Wakanda and Zion respectively. Now, A and B form 40% and 30% of the total cost. Current gain is 20%. Due to change in scenario, the cost of Zion markup is increased by 20% and that of Wakanda is decreased by 15%. And the remaining cost remains the same. Write the gain if the selling price does not change. Right? So, two components are there, A and B. A and B. Right? They are sourced from Wakanda and Zion. So, Wakanda and Zion. Now, this form 40% of the total cost. This is 30%. So, that means remaining is 30%. Right? Because obviously remaining cost is there. Right? And gain is given to be 20%. Right? Okay. Due to change in scenario, the cost of Zion mark, as in this one, is increased by 20%. So, increased by 20%. And this is decreased by 15%. Right? And the remaining cost remains the same. Now, write the gain if the selling price does not change. Right? Now, since you see the percentages are getting involved and nothing is given, I will suppose my total cost to be 100. Right? So, 40% of 100, that is 40. So, I'll take the share of component A to be 40 and component B would be 30 and the remaining would be 30. So, total cost, you can see the cost price, that is 40 plus 30 plus 30, that is what? 100. Now, he says since gain is 20%, the selling price would be what? 120. Right? Okay, now come here. Now, he says the cost price is decreased by, here, it is decreased by 15%. So, 10% of 40 is 4, 15% would be 4 plus 2, 6. So, 6 has been decreased, so this becomes 34. And 20% increase, 10% is 3, 20% would be 6, so this becomes 36. Right? And remaining cost remains the same. Right? Now, let's just check the cost price. 34 plus 36 plus 30. Cost price is 100. And he says write the gain if the selling price does not change. So, selling price is 120. Now, cost price is still 100. Selling price is still 120. The gain would be what? 20%. So, you need to write the gain. That is why the is 20. Right. Now, he says, let 2 raised per r be the remainder when this number is divided by 2 raised per 25. Write the sum of squares of the digits of r. So, basically, I need to find the value of r. Now, he says this is the remainder when this number is divided by this. Right? So, 3 raised per 2 raised per 20. 22, oh, which is this here, coincidence, minus 1. When this is divided by 2 raised per 20, 25, there would be some question and there would be some remainder which is of the form 2 raised per r. Right? Now, if I want to find out this, I need to find the remainder. That means out of this, if I can see, if I can find out how many 2 raised per 20, 25 are there. Right? Probably the remaining part I can see, that is the remainder. So, basically, I need to see how many 2's are present in this. This is a very weird number, but 3 raised per something, which is even, by the way, minus 1. Can't you see that this is of the form a square minus b square? I can easily factorize this. No? Let's try it out. So, this is the number. So, I can write this as 3 raised per 2 raised per 20, 21 into 2. No. Into 2 here. I've separated 1, 2 out. Why? Because I can write this as 3 raised per 2 raised per 20, 22. Like this. Because these two get multiplied. These two get multiplied. Right? So, I can write this term as like this. And here 1 aana chahiye. So, I can write this as minus 1. So, this is technically a square minus b square. So A minus B, so that is 3 raised power 2 raised power 2021 minus 1 into 3 raised power 2 raised power 2021 plus 1. Right? Now further, again you can see, if I can write this as 3 raised power 2 raised power 2020, right, into 2, that means I can put the bracket and it goes like this. So again, this is nothing but this minus 1 whole square. So this factor can further be written as a square minus b square. So I can write it further like this. I'll write it here. So this becomes 3 raised power 2 raised power 2020 minus 1 into 3 raised power 2 raised power 2020 plus 1. This factor I wrote it like this and this I wrote it like this. And into this factor, don't forget about this. So 3 raised power 2021 plus 1. Can you see? Further you will write it and this will actually become, I'll write the factors directly, 2 raised power 2019 plus 1 minus 1 into 3 raised power 2 raised power 2019 plus 1, and this factor as it is 3 raised power 2 raised power 2020 plus 1, and this factor as it is 3 raised power 2021 plus 1. And further you will factorize it and the cycle will start. Right? So I will leave that up to you. I will just directly write it here. I'll write it here. So this number ultimately comes out to be, factorize it repeatedly, you will get it like this. So 3 raised power 2 raised power 2021 plus 1 into 3 raised power 2 raised power 2020 plus 1 into 3 raised power 2 raised power 2019 plus 1, and so on. I'll get 3 raised power 2 raised power 1 plus 1, right, because powers of 2 are decreasing, into, so I didn't need this space but I'll write like this, into 3 raised power 2 raised power 0 plus 1 into the last one would be 3 raised power 2 raised power 0 minus 1, because obviously you cannot further factorize this. Done. So I have written this number in the form of this. Why? Because I want to see how many powers of 2 are getting involved. Why? Because I need to divide this number by this, which is basically powers of 2. Right? Now let me see how many powers of 2 are there. So this is nothing but 3 minus 1. So just 2 raised power 1 is there. This is 3 plus 1, which is 2 square. This is 9 plus 1, which is 2 raised power 1. Right? Next you can find out 2 raised power 1. Now which is a very peculiar thing. 2 raised power 1, 2 raised power 1. I need to see whether from all of these in between numbers, how many powers of 2 are getting. Now, mind it, this 3 raised power something, right? 3 raised power something will be an odd number. Odd number plus 1, even number, even number, even number. Each of these numbers from here onwards, they are even, that means 1 power of 2 would be there. Now the question is whether the second power of 2 would be there. That I can easily check if I can find out whether the numbers like these are divisible by 4 or not. Interesting. Okay, now divisibility by 4. Now divisibility by 4, maybe I can find out the form of the number. Here I have, suppose, let's start with this. So 3 raised power 2 raised power 2021. Right? Now 3 is there, that means I can write 3 as divisibility by 4. That means I can write 3 as 4k minus 1. Right? And raised power 2 raised power 2021. Right? Basically, I am multiplying this factor of 4k minus 1. How many times? 2 raised power 2021 times. That means it will be even power only, even. I am multiplying this factor even number of times. So if I am multiplying the factor even number of times, right? Just imagine. Right? What will happen to this minus 1, minus 1, minus 1? This will actually become plus 1. Right? And from the earlier terms, obviously you can get 4 common. So basically, it will be of the form 4L plus 1. You can say 4k plus 1 is absolutely fine. Right? So that means this number is of the form 4L plus 1. I am not talking about this number. I am talking about this plus 1. So plus 1. That means this thing, this number is actually of the form 4L plus 2. That means it is not divisible by 4. Right? So just one factor of 2 I'll get. And this similarly you can see this will be of the form 4L plus 1 here. So again 4L plus 2. That means not divisible by 4, not divisible by 4, not divisible by 4, not divisible by 4. So from here, all of these factors, you're just getting the power of 1. Right? Now let's see how many powers of 2 do I get. So from each of these factors, so 2 raised power 1 se leke 2 raised power 21 tak. So I'm getting 2 raised power 21. Right? So 2 another, 1 another, so 3 more. So I am getting 2 raised power 24. Right? So this number, I have extracted out all the powers of 2. But still obviously something is multiplied by it, right? Now I have extracted all the powers of 2. That means what I will be left with is the odd number. Now odd number, the form of odd number. It will be of the form 2m plus 1. Right? So this number I have written as 3 raised power 2 raised power 2022 minus 1 is equal to this. Right? So let me open this up. This is multiply. So 2 raised power 2025 into m plus 2 raised power 2024. So do you see? This is equal to 2 raised power 25 into some question, and this has to be the remainder. So 2 raised power r. So that means r is equal to 2024. Right? Then you need to find the sum of the squares of the digits of r. You can very well find it. The answer will turn out to be 24. Alright. On to the next one. He says 2 circles of radii 10 root 2 and 2 root 2 touch each other internally. Okay. So I have one such circle and another such circle. Now radii are given 10 root 2 and 2 root 2. Right? Not bad. Okay. A chord AB of the larger circle touches the smaller circle and forms an angle of 45 degrees with the common tangent. Right? Now obviously common tangent would be like this. This would be common tangent. Right? Now AB is the chord of the bigger circle and it touches the smaller one. So maybe my chord is something like this. Or maybe I should make it more dramatic so that you can see the angles properly. Cool? Right. So it is something like this. Right. So this is my chord AB. And it makes an angle of 45 degree with the common tangent. So that means this angle is 45 degree. Right. Now he says if AB is equal to K, then write the value of this. So basically you need to find the value of AB. Right. Now what is given to you? It is given that the radii is 10 root 2 and radii here is 2 root 2. Right. Okay. Now obviously since I want to find the length of the chord and the center. So I can drop a perpendicular. Right. And obviously this is the radius which is given to me, that is 10 root 2. And I know that perpendicular from center will actually bisect the chord. So instead of finding AB, I will try to find AC. Why? Because that will be the half of AB. So let me try to find out this length. Now in the triangle OCA, I already know that this is 90, this is 10 root 2. If I want to find AC, I need to find OC. Right? If I need to find OC, what can I do? OC. Now let's see. Obviously here it is a tangent, that means I can have 90 degree over here. Also I know common tangent point is there, that means this center and this point of contact, they will be collinear. Right? And this would be 90 degree. Okay. Somehow I have to make use of the fact that this is 45. Right? This is 90, this is 90, this is 45. Can you tell me this angle? This is 135. Now, if this angle is 135, can you say which angle is 45 degrees? Right? Obviously, this angle is 45 degrees. Okay. Now, wait a second. This is 45. Here pe 95. That means this angle is also 45. Okay. So, let me name this point. This point, let that be D, and this point, let that be E. Now, in this triangle O-D-E, can I say that this length is equal to this length? O-D will be equal to DE. Isosceles triangle is there. Right? And O-D is nothing but the radius of the smaller circle. This is equal to 2 root 2. We'll see where we have to use it. Don't worry. right? Now, what else? Let me just write it. So this is 2 root 2. This length is also 2 root 2. Okay, what else? Now this angle is 45, right? This angle is also 45. The red one, I'm not writing it because I don't have space, right? And this angle is also 45, right? So in triangle OCE, I have 245, that means this is isosceles triangle, right? That means OC will be equal to C. Interesting. OC will be equal to C. I am interested in OC. That means OC is equal to C. Somehow I need to find OE. I need to find OE. अच्छा, मुझे पता कौन सी है? मुझे length पता है OO dash. What is the length? OO dash, distance between the centers. This entire thing is 10 root 2. This is 2 root 2. That means this is 10 root 2 minus 2 root 2. That is 8 root 2. Right? This entire length, I know. Let me change the marker so you can see it better, probably. Right? Okay. Since I want OE, I need to find out this length. This length. How do we find out this length? Let me see. This length was 2 root 2. This length was 2 root 2. This is 90. This is the hypotenuse basically. Can I find out this length? This will turn out to be, this is 4 into 2, 8. This is 8. 8 plus 8, 16. So that means this length will turn out to be 4. So O dash E turns out to be 4. Now this is 8 root 2. This is 4. That means OE length. That is 8 root 2 minus 4. Right? Done. I know this length. I need to find OC. Why? Because I need to find the length AC. Right? So put this OC as X. This is X. In triangle OCE, just apply Pythagoras theorem and your answer will be there. After some calculation. In triangle OCE, you can say this square, which is x square, plus this square, which is x square, so 2x square, is equal to OE whole square. OE is where? Here. 8 root 2 minus 4 whole square. Right? You can find the value of x square, right? Because when you apply Pythagoras theorem in OCA, you need x square only. So AC square is actually nothing but this square, which is 200, minus OC square, which is x square. Get x square from here, put it here, get the value of AC, double it up, and you will get the value of AB. Then divide it by square root of A plus 2 root 2. It is not that hard. You have to do it. The answer will turn out to be 0, 8. Alright. On to the last and the most interesting question of the paper. Let's see. Oh, it has the word interesting in it. Interesting. A 10-digit number is said to be interesting if its digits are all distinct and it is a multiple of 11,111. Let k be the number of interesting integers. Write the sum of the digits of number k. Basically, I need to find the number of interesting digits. Now, interesting digits, it's a 10-digit number. So, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And its digits are all distinct. So, A, B, C, D, E, F, G, H, I, J. So that I can see that all the digits are distinct. But I know that A will lie between 1 and 9, B will lie between 0 and 9, C will lie between 0 and 9, and so on. And it is a multiple of 11,111. This number is divisible by this. Now, what else do I know? Divisibility. Let's talk about divisibility. This number is divisible by this. Do you think this number will be divisible by some other number? Now, he says all the digits are distinct, right? Now, how many digits are there? 10 digits are there. That means 0 to 9, all the digits will be involved in the number. Right? 0 to 9, all the digits are involved. Now, if I add 0 plus 1 plus 2 plus 3 plus 1 till 9, as in sum of first 9 natural numbers, that turns out to be 45. If I add all the digits, the sum turns out to be 45. Sum is divisible by 9 because 45 is divisible by 9. If sum of the digits is divisible by 9, the number is divisible by 9. So I just established, since we were talking about divisibility, I just established that this number is divisible by this as well as this. Now obviously these two are co-prime numbers. That means the numbers would be divisible by 99,999. Right? 99 comes. So basically this is nothing but 10 raised to power 5 minus 1. Right? But the question is, what is the benefit of this? I need to find the number of interesting digits. So basically the corresponding values of A, B, C, so on till J. Right? Okay. Now I only know that this number is divisible by this or this. Now since divisibility, I'm talking about divisibility, somehow I need to generate 10 raised to power 5. Now I can write the number in the expanded form, but I need the expanded form to definitely include 10 raised to power 5. Right? So I will write expanded form in a different kind of manner. What I'll do is, I will take this number. Right? I will write the expanded form A, B, C, D, E into 10 raised to power 5. Right? 1, 2, 3, 4, 5 plus F, G, H, I, J, whatever this number is. I've specifically written the expanded form in this way. Why? Because I wanted to involve 10 raised to power 5 because I can see. Right? Okay. Now, this number, this is the same number basically, this number is divisible by 10 raised to power 5 minus 1. Right? If we divide this, let's see what happens. Let me divide this by this. We know how division works, right? So this is the divisor 10 raised to power 5 minus 1. And that is my number A, B, C, D, E into 10 raised to power 5 plus F, G, H, I, J. Right? So obviously, since this is there, I'll do 10 raised to power 5 into A, B, C, D, E. So this into this is the first quantity, A, B, C, D, E into 10 raised to power 5 minus A, B, C, D. Right? Subtract it, minus, plus. This gets cancelled. So basically, I'll get A, B, C, D, E plus F, G, H, I, J. Now, since I know that this number is exactly divisible by this. So this remainder that I'll get, right? What can be the possible forms of the remainder? Now, remainder, obviously this is not 0. So that means whatever this comes, this has to be divisible by this. So that means this number, A, B, C, D, E plus F, G, H, I, J is divisible by what? Which number? 10 raised to power 5 minus 1, which is 99,999. This number is divisible by this. Right? So divisible है, ये number हो क्या कह सकता है? Right? Either this number can be this or some multiple of this. Or maybe I can say 2 into 99,999. Okay. And or possibilities नहीं बनेंगे because adding 2 5-digit numbers will not give me 3 into 99 raised to power 99,999, right? Or multiples नहीं बनेंगे. So now that I think about it, even this multiple is also not possible. Why? Because if you can see A, B, C, D, E, all the distinct numbers are there. Definitely this number is less than 99,999. Also, all the digits are distinct. So F, G, H, I, J, definitely less than 99,999. If I add these two, right, add them up. Don't you think it will be less than 2 raised to power 99,999? Right? So this term is less than this. So equal कैसे होगा? The only possible case is if I add these two, that can be equal to or that must be equal to 99,999. Alright. Okay. Now this is a very interesting condition that we have arrived on. Right? So I am going to erase this because I need the space. Now we have approached that, we have arrived at that A, B, C, D, E plus F, G, H, I, J. In fact, let me write it like this so that I can better see it. F, G, H, I, J. If I add the two, I will get 99999. Right? Now mind it, I have to have E plus J and the unit digit has to be 9. Now this is a digit. Maximum can be 9 and maximum here can be 8. Right? 9 plus 8, that means 7. उससे पहले 6, then 5, then 4, then 3, 2, 1, 0, then 9. 9 can only be possible if E plus J is equal to 9. Right? Similarly, here 9 will only be possible if D plus I is equal to 9, and C plus H is equal to 9, and B plus G is equal to 9, and A plus F is equal to 9. Right? If this has to be satisfied, this has to be satisfied. Now, mind it, I need to write 9 as sum of two numbers, right? And how many different ways can I do that? I know that digits are 0 to 9. So, let's see. 0 or 9, 1 or 8, then 2 and 7, 3, 6, 4, 5. And then repetition is there. Let me write it down. 5, 4, 6, 3, 7, 2, 8, 1, and 9, 0. Right? So if I'm talking about E and J, right? Either EJ will be 0, 9 or 1, 8, 2, 7, 3, 6, 4, 5 or 5, 4. You can see the 10 possibilities. Right? So let me see. E, J. Right? Any of the 10 possibilities it can be. Right? So 10 different ways. Corresponding to this, now let's talk about D and I. Right? Suppose for E and J I took 1, 8. Right? Now, D and I, do you think it will have 1, 2, 3, 9 possibilities? Careful. If I have rejected 1, 8, I cannot take 8, 1. Digits are distinct. 1 and 8 have been used. That means I cannot use this. So, D and I will have 8 possibilities. Right? Now, let's talk about C and H. C and H. Suppose for D and I took 3 and 6. So, 6 and 3 already rejected. So, C and H will have 6 possibilities. Right? B and G will have 4 possibilities, and A and F will have 2 possibilities. Right? So, you can find that out. But we did one thing wrong. What was it? I need a 10-digit number. 10-digit number, that means, do you think A can be 0? No. A cannot be 0. But you have counted here when A is equal to 0. That's it. So subtract the cases. You have counted extra cases. Just to subtract the extra cases. Let's see. What are the extra cases? When A is 0, right? Now if A is 0, F has to be 0. So that means you have taken the case of 0 and 9. And then BG as it is. Then CH as it is. Then CI as it is. And EJ as it is. Right? Now let's see how many cases would be there. Now this is fixed. Now BG. Now 0 and 9 have been fixed. Okay, so ignore, just focus on this marker now, ignore the red one, right? So 0 and 9 have been rejected, 9 and 0 have been rejected. So BG either can be 1, 8, 2, 7, 3, 6, 4, 5 or 5, 4, 6, 3, 7, 2, 8, 1. So that means it has 8 possibilities. Right? So if I take BG to be 2, 7, along with this I will reject 7, 2 also. Distinct digits are there, don't forget it. C and H will have 6 possibilities. Then corresponding B and I will have 4 possibilities. E and J will have 2 possibilities. So these are the number of cases when 0 is at the first place and I don't want these. So subtract this minus this one. 8 into 6 into 4 into 2. Right? You subtract it and you will get the number which is a very nice number. I'll write it here. 3, 4, 5. Right? This is the number of interesting digits. Now, the number of interesting digits is also interesting because 3, 4, 5, 6. Right? So, then K is this. Write the sum of the digits of number K and that turns out to be 18, which is the final answer. Right? So, obviously as you can see, the last question was the most interesting one. Right? So, with this we conclude our discussion of the test. Hopefully you have noted down your mistakes. Hopefully you are still preparing for the Olympiad paper / KVPY paper that will be held. The main part, the most important thing that you have to remember while attempting the paper, most important, that is to have fun. Right? These are the questions are actually quite interesting as you can see. Right? These are not the usual boring kinds that you do. So please try to have fun during the paper. Then along with the fun, please have your numerical ability on point and concentration on point. So even if you get the concept, you have to do the calculation right in order to get the correct answer. All right. So with this, let's just end it. I will see you next time. Thank you.